Alrighty, this is page 2 of my description of digital physics, my simplified description of digital physics. And in the document that I'm reading this from, which is called Explain the Reverse Time Ordering of Light, Part 1 of 3, Introduction and Prerequisites of Digital Physics, as demonstrated in Introductory VB6 Programming Language, I say that this page is very important because this is the page where we're defining the motion of matter and time. All right, now you can see I got big, bright, colorful highlighting and stuff like that. By changing the value of any of these numbers, we change the location of the particles. We move matter around from state to state. Simple integer arithmetic applied to the list of numbers accomplishes all of this. I'm going to read this one more time. By changing the value of any of these numbers in the lists, we change the locations of the particles. In other words, we move matter around from state to state. Just by changing the number, we're changing the location it's being pointed to, right? We're changing the pointer. That's like moving the particle, right? Simple integer arithmetic applied to the list of numbers accomplishes all of this. For example, algorithm number 1. I highlight all my algorithms in gray in this document here, okay? Algorithm number 1 says add 1 to the odd numbered entries, okay? Now, when we apply this set of instructions right here, known as an algorithm, to the list of numbers, we get a new state. We're going to call that state 1 for our simple 3-particle universe example here, okay? So state 1 looks like this, right? I hope you can see it. I'm not sure I made this so small here, but remember state 0 looked like this, 2, 5, and 7. And state 1 is 3, 5, and 8 because we added 1 to the odd numbered entries, right? And the odd number list entries, well, entry number 1 is odd and entry number 3 is odd. And notice we're doing calculations based upon the index of the list, not even the context of the list. You can see how this is a little different than typical physics, right? So we add 1 to number 1, and it goes from location 2 to come on, yeah, up to location 3. We leave entry 2 alone because it's got an even number on it. And then we, for entry number 3, which was 7, yeah, and we turn it into 8. Yeah, pretty cumbersome. Okay, so I'm saying here, particles numbers 1 and 3 were moved 1 position to the right by adding 1 to it. Okay, now this should have been a new paragraph here. Okay, we can apply the algorithm to the list again and come up with yet another state, which we're going to call state 2. So we apply this algorithm number 1, add 1 to the odd list entries again. We apply it to state number 1 to get state 2. So we turn 3 into 4, and we turn 8 into 9, and particle 5 is left alone because it's not got an even index, not on an index. And here's what state 2 looks like here. And now here's what the magic comes right here. Watch this. I hope you can see it. Here's what these state changes look like in our data visualization, right? So state 0 was just like it was above, remember? Oh, God, hang on a minute. Wait a minute. Sorry about that, okay? So that was state 0, just like it was before. Now state 1 was we added 1 to location, to particle number 1's location. That moved it over to location 3, and we did that to particle number 3 as well. And what I'm saying is here, can you visualize particles number 1 and 3 hopping to the right. In each state transition, this is virtual reality in its simplest form. What I'm showing you here is how matter can start moving around relative to itself, and how it can all be done with very, very simple digital physics, all integer arithmetic, real simple stuff. Each state change is one application of the algorithm. Now, what I'm going to say now is the most important thing you're ever going to hear in your life ever so far, okay? And so, by continuously applying it in a successive series of applications, this is how the universe implements the motion of matter through time. I just showed you what time is. Time is the sequential execution of the application of this algorithm to the list of numbers. This is how the universe implements and tracks time. There is no system clock. The repeated sequential execution of the algorithm itself provides the tempo of time. Thank you.